I hope all of you are doing good. Let's start today's chapter, cubes and cube roots. Introduction. In the previous chapter, we have learned about squares and square roots. In this chapter, we extend the idea of a square and square roots to cubes and cube roots. While we can find square roots of positive real numbers only, cube roots are defined for both positive and negative numbers. Cubes. The cube of a number is that number raised to the power 3. Thus, if a is a number, then the cube a is a raised to the power 3. That is a into a into a. Means we have to multiply the number 3 times. Okay. So, 2 raised to the power 3 is what? 2 into 2 into 2 is equals to 8. 3 raised to the power 3 is 3 into 3 into 3. That is 3 3s are 9, 9 3s are 27 and so on. Cubes of natural numbers and perfect cube numbers. Cube of a natural number. The cube of a natural number is that natural number raised to the power 3. Thus, if n is a natural number, then n raised to the power 3 is the cube of n, and we have n raised to the power 3 is equals to n into n into n. Perfect cube. A natural number is said to be a perfect cube if it is the cube of some other natural number, right? Thus, a natural number m is a perfect cube if there exists a natural number n whose cube is m. For example, 8 is a perfect cube because 8 is equals to 2 into 2 into 2, that is 2 raised to the power 3. Also 27 is also a perfect cube because 3 raised to the power 3 is 27. Okay. Similarly, 64 and 125 are perfect cubes of natural number 4 and 5. Okay. Now, the question is, how can you find if a given number is a perfect cube? We follow the given procedure. If a prime number p divides m, then p into p will divide m into m into m. That is, p raised to the power 3 will divide m raised to the power 3. Thus, if a prime number p divides a perfect cube, then p raised to the power 3 also will divide the perfect cube. If we put in other words in the prime factorization of a perfect cube, every prime number occurs 3 or a multiple of 3 times. Thus, we have 64 is equals to 4 into 4 into 4, that is 4 raised to power 3, and 2 into 2 into 2 into 2 into 2 into 2, that is 2 raised to the power 6. So, to find out if a given natural number is a perfect cube, we follow the procedure given below. Procedure, step 1, we express the given natural number as a product of prime factors. Step 2, we group the factors and triplets in such a way that all factors in each triplets are equal. Step 3, if no factor is left out in the grouping in step 2, then the number is a perfect cube. To find the natural number whose cube is a given number, take one factor from each triplet and multiply them. The cube of the numbers obtained will be the given number. Let's do example 1. Is 128 a perfect cube? So, first we will find the prime factors of 128. Then we will group the factors in triplets of equal factors. Okay. So, 1, 2, 3, one group, 1, 2, 3, one group, but 1, 2 is left out. Okay. So, that means that is 128 is not a perfect cube. Okay. Some properties of cubes of numbers. The cubes of first 10 natural numbers are given below. Okay. Don't forget to memorize the cubes of these numbers. Okay. So, from the table it is clear that cubes of digits 1, 4, 5, 6 and 9 are numbers ending in the same digit, that is 1, 4, 5, 6 and 9 respectively. 2. The cube of 2 ends in 8 and the cube of 8 ends in 2. Wow, this is so interesting. And number 3, the cube of 3 ends in 7 and the cube of 7 ends in 3. 4. If a number ends in 0, then its cube will end in 3 zeros. 5. The cubes of all even natural numbers are even, while the cubes of all odd natural numbers are odd. 6. The sum of the cubes of first n natural numbers is equals to the square of their sum. That is 1 cube plus 2 cube plus 3 cube plus up to n cube is equals to 1 plus 3 plus n square. The proof of this statement is beyond the scope of this book. 7. If a number is negative, then its cube is also negative. Remember that, okay, if a number is negative, then its cube is also negative. Finding cube of a 2-digit number by column method. We know that cube of a number can be obtained by multiplying the number by itself thrice. Often this is tedious. The column method is comparatively easier. Let x is equals to ab, or 2-digit natural number where a is the 10th digit and b is the unit digit. Recall that for finding a plus b square, we formed 3 columns: minus a square, 2ab and a b square. Similarly, for finding x cube is equals to AB raised to the power 3, we form 4 columns containing A cube, 3 into A square into B, 3 into A into B square and B cube. So we shall illustrate this with the help of the following example. Okay. So for here we have to find the cube of 27 by using column method. So 2 is what? A, and B is what? 7. Okay. So column 1 is A cube, means 2 cube, that is 8, right? Column 2 is 3A square B. Okay. 3A square B means 3 into A is 2, 2 square into B is what? 7. That is 3 into 4 into 7 is 84. Now, next third column is 3AB square, that is 3 into 2 into 7 square, right, which is equals to 294, and 4 is B cube, that is 7 cube, and 343 is the cube of 7. Now, what will you do? You will add 11 to 8, okay, so you will get 19. Then 84 plus 32 is 116. We will write only once a digit, okay. 294 plus 34, 328, so we will write only 8, and 343, unit digit is 3. So the cube is, we will write all 3 digits, 19683, okay. Exercise 4.1, find the cubes of the following numbers. 8 cube, 8 into 8 into 8, 8 into 8 is 64, 64 into 8 is what? 32, 512, okay. Cube roots. A number m is the cube root of a number n if n is equals to m cube, or the cube root of a number n is that number m whose cube gives n. Cube root of a number n is denoted by this, cube root of n. So this is also called a radical, where n is what? N is radicand, and 3 is what? Index of radical. So we have 8 is equals to 2 cube, or you can write as 8 cube is equals to 2, or cube root of 8 is 2, right? Similarly, 27 is equals to 3 cube, and cube root of 27 is 3, okay. Remark, this symbol, okay, not this, this is the symbol for the cube root, is very much similar to a symbol for square root, that is this one, but it is often a mere convenience that we omit 2, we don't write 2 most of the time, but we never omit 3 from cube roots, okay. Cube root of a natural number. A natural number m is the cube root of a natural number n if n is equals to m cube, and write like this, 3 cube root is equals to m. Now, computation of cube root through a pattern. In order to calculate the cube roots of small numbers which are perfect cubes of natural numbers, we can use this method, like squares of natural numbers. Cubes do have interesting patterns as explained below. So we know that 1 cube is equals to 3 raised to the power 1, or you can also write 1 raised to the power 3 minus 0 raised to the power 3. That is 1 is equals to 0 into 6 is equals to 1 plus 1 into 0 by 2 into 6, okay. 2 raised to the power 3 is 8. So 2 raised to the power 3 minus 1 raised to the power 3, that is 8 minus 1 is equals to 7, or 1 plus 1 into 6. So 1 plus 2 into 1 upon 2 into 6, okay, and so on. So the pattern, this pattern suggests that the following method to find cube root of a perfect cube of a natural number. Procedure. Step 1. From the given natural number, subtract 1. If we get 0 as the result, the cube root of the number is 1. If not, we go to step 2. Step 2. Subtract 7, or 1 into 2 into 1 by 2 into 6. Okay. You can either subtract 7 or this from the resulting number obtained in step 1. If the result is 0, then cube root of the given number is 2. If not, we go to the next step. Step 3, subtract 19 or this from the number obtained in the previous step. If we get 0, the cube root of the given number is 4. If not, we go to the next step. We continue this process till we get 0. The cube root of the given number will be equal to the number of times the subtraction is performed. However, this method is suitable to find the cube roots of small natural numbers only. Now, let us consider some examples. Find the cube root of 64. Okay, so we have clearly subtraction has been performed 4 times. See, 64 minus 1 is 63. Now, we will subtract 7. Okay, so this is 56. Now, subtract 19. Then we will get 37. Now, subtract 37. So, how many times we have subtracted? 1, 2, 3 and 4. That means cube root of 64 is what? 4, right? Now, cube roots of a number by using its unit digit. While discussing the properties of cubes of natural numbers, we have seen that units digit of cube of a natural number depends on the units digit of the given number. Consider the table given below. See, unit digit of the number n, that is 0, unit digit is 0. If 1, then unit digit is 1. Okay. Cube root of 3, 2. Cube of 2, unit digit 8. If we are finding cube of 3, unit digit is 7 because 27. Cube of 4 is 64, so unit digit is 4. So, you should go through this, okay. So, by looking at the unit digit of a perfect cube number, we can determine the unit digit of its cube root. So, we follow the steps given below. Step 1. Look at the digit at units place and determine the digit at the units place in the cube root by using the above table. Step 2. Strike out from right last 3 digit, that is units, tens and hundreds of the number. If no digit is left out, then the digit obtained in step 1 is the cube root of the number. Otherwise, we proceed further. Step 3. Observe the number left at step 2. We find the largest single digit number whose cube root is less than or equal to this leftover number. This number is the 10th digit of the cube root. 4. Write the cube root as the number whose unit digit is a digit obtained in step 1 and 10th digit is the digit obtained in step 3. Let's find the cube root of 125. Okay. So, here the unit digit is what? 5, right? The digit at units place in the cube root is 5. So, no number is left after striking units, tens and hundreds digits. Hence, cube root is what? Cube root of 125 is 5 only, right? Now, cube root by prime factorization. We can find the cube roots of numbers by using the following procedure. Step 1. Find the prime factorization of the given number. 2. Group the factors in triplets such that all 3 factors in each triplet are the same. 3. If some prime factors are left ungrouped, the given number is not a perfect cube and the process stops. 4. If no factor is left ungrouped, choose one factor from each group and take their product. The product is the cube root of the given number. For example, we have to find the cube root of this number 5314441. So, we will use the prime factorization method. Okay. So, after finding out the prime factorization, we will group in 3 number 1, 2, 3, 1 group 1, 2, 3, 1, 2, 3. Okay. So, here we have formed 4 groups of 3, that is 3 into 3 into 3 into 3. 3 into 3, 9, 9 into 3, 27, 27, 3, 81. That means this number is cube root of 81. Okay. Cube root of negative integral perfect cube. We know that for every integer x, minus x is a negative integer such that minus x raised to the power 3 is minus x into minus x into minus x. And minus x cube root of minus x cube is equals to minus x, and cube root of minus x cube is equals to cube root x cube into minus 1 is equals to cube root of x cube. Thus, the cube root of a negative perfect cube is negative of the cube root of its absolute value. In other words, to find the cube root of a negative perfect cube, we find the cube root of its absolute value and multiply it by minus 1. For example, we have to find the cube root of minus 1728. First, we will find the prime factors. So, after finding prime factorization, let's group them. 1, 2, 3. So, 2 into 2 into 3, that is 2 2s are 4 and 4 3s are 12. So, cube root of minus 1728 is what? Minus 12, right? Cube root of product of integers. For any 2 integers m and n, we have cube root mn is equals to cube root of m into cube root of n. Okay, now find the cube root of each of the following, which is minus 512 into 1728. Okay, cube root of 500 minus 512 is what? 8. Okay, and 1728 is what? 12. Okay, so 8 into 12 is what? 96, and minus 96 because it is minus 8. Okay, right? Cube root of rational numbers. We know that 2 by 3 raised to the power 3 is equals to 8 by 27. That is 8 by 20. Cube root of 8 by 27 is equals to 2 by 3, or you can also write cube root 8 upon cube root 27. Similarly, minus 3 by 4 raised to the power 3 is similar, but the difference is that we will put a negative here. So if x and y are perfect cubes and y is not equals to 0, then x by y cube root is equals to x cube root upon y cube root, right? Thus the cube root of the quotient of two perfect cubes is the quotient of their cube roots, right? Exercise 4.2. Find the cube roots of each of the following numbers by successive subtraction of numbers. 1, 7, 19, 37. Okay, you have to subtract all these numbers. Okay, so start from 27. First we will subtract 1. We will get 26. Now we will subtract 7. What will we get? 16 minus 7 is what? 9. Then now subtract 19. 0. So how many times we have subtracted? How many numbers we have subtracted? 1, 2 and 3. So 27 is the cube of 3. Okay, or you can say 3 is the cube root of 27. Okay. Things to remember. The cube of a number is that number raised to the power 3. If m is a number, then m cube is equals to m into m into m. 2. A number m is a perfect cube if m is equals to n raised to the power 3. Here n is the cube root of m and written as like this. Okay. 3. The cube of an even natural number is even and the cube of an odd natural number is odd. 5. The units digit of the cube root of a perfect cube can be obtained with the help of the units digit of the perfect cube. 6. The cube root of a perfect cube can be obtained by the prime factorization of the number. 7. The cube root of a product of two perfect cubes is the product of the cube roots of the perfect cube, that is mn under root cube root of mn is equals to m cube root into n cube root, where m and n are perfect cubes. 8. The cube root of a quotient of two perfect cubes is a quotient of their cube roots, that is m by n cube root is equals to cube root of m upon cube root of n, where m and n are perfect cubes and n is not equals to 0. 9. The cube roots of a negative perfect cube is negative, that is minus m cube root is equals to minus m cube root, where m is a perfect cube. And 10. Approximate values of cube roots of numbers can be found using cube root tables. Okay students, now here comes the end of this chapter. Now you will do practice of the remaining questions.